So I'm going to be honest with you. I'm really bad at mapping things between different ranges. And for me, this comes up all of the time in software engineering. So one example is if I'm trying to create even 2D video games and I have to think about mapping things between different coordinate spaces, I just can't do it. For some reason, it doesn't click in my brain, and I have to resort to getting on pen and paper and drawing it all out. And even then, translating those ideas into code, they just never seem to click. This problem even exists for me when it's not two-dimensional. So if I have to map between different arrays of data and different ranges, I struggle with that all the time. In fact, I spent about 8 years of my career writing digital forensics software, and we had to do this non-stop. We had to go look at unstructured data, take ranges of that, and go structure it to make sense of it. So why am I telling you this aside from just being vulnerable and sharing that I have some weaknesses as well? Well, this all comes back to testing. And when I talk about testing, I refer to testing as one of the best tools we have to build confidence when we're making changes to code. And for me, when I'm really struggling with things like being able to map ranges of data between different coordinate spaces or even just between arrays, when I finally get my algorithm working, this is something that I'm making sure that I have a ton of test coverage on. Because if I need to iterate on that at all, I want to make sure that different parts of that algorithm aren't totally falling apart. Additionally, because of the experience that I have, I know I struggle with mapping ranges. So for me, having more tests means more confidence in this area, and that way, when I finally have it working, I can feel safe to move on to something else and not have this brittle thing that I was worrying about in the first place. So I wanted to walk through some code like this with you today because I actually had some recent code working with caches where I had to map ranges of data, and it was a perfect opportunity to go write a bunch of unit tests on it. So before I jump over to Visual Studio, I just want you to pause for a second and think about if there are things that you always seem to struggle with when you're programming. For me, it's mapping ranges of things. For you, it might be something else. So think about that. And then as we're walking through this code and I'm talking about my testing, I want you to think back about the thing that you struggle with and see how you can apply your tests to these situations. And with that said, let's jump over to Visual Studio. All right, so in my most recent videos, I've been talking about caching a lot. And recently, I posted a video about this result set cache, which I will link up above so you'll see a little thing in the top that you can go click on and watch if you haven't seen that already. Just briefly, the idea behind these result sets and the caching is that if I have a page of data that I'm pulling back from a database based on a filter, I want to make sure that I can organize these in a cache so that I can retrieve them later. And I need to be able to merge the pages together, and that's going to bring us back to this concept that for me, I really struggle with. Because I'm going to have to map ranges of data to try and merge these pages, that's something I really struggle with. In addition to merging, we also have a method on this result set cache that allows us to try and get a page out. Now, if we already have a bunch of pages inside of this result set, we can actually ask for an offset and a page size to get a partial page or some page that might overlap several pages together. Again, that brings us back to this range mapping thing that I totally suck at. If we scroll down a little bit further, we can see in this part of the method here, we're actually looping through the pages and trying to find the pages that map to the range we're looking for, and then we're going to be adding those IDs from the result set into the result that we're going to return to the caller. The details of this aren't super important for what we're about to discuss, but I just wanted to show you that this is part of the method that's giving me a ton of headaches when I think about how I need to implement this, and so that I can have confidence that it's working as expected. If I jump over to the result set cache class, it's very similar in the sense that I have to do some range mapping, and it really screws me up. Inside of this method to set async, we're actually able to take in a result set page, and this is where, if I scroll down a little bit lower, we're going to do some logic to actually insert a page and then try to merge the pages after. In fact, this algorithm can likely be highly optimized, but I didn't know how to do it yet, and because it was functioning and I had tests over top of it, now I'm actually in a position where I have confidence in its performance and its behavior, and I'm able to go iterate on that because the nice thing is currently it's working. If I expand this code a little bit just so we can have a look at it, this part that's going to insert a page is actually going to look to see where it can insert the page, and then from there it either inserts it or it's going to add it to the end if it's not part of an existing range already. Again, this logic probably could have looked for a page that it's going to line up with and tried to merge it. However, I just wasn't sure how to go do that. And I'm totally comfortable admitting that this is something that always really screws me up because I've seen it time and time again with different applications, and it always comes back to haunt me. The nice thing is I have a tool and it's called testing, and I always end up applying it for me to get that confidence that I need. If I scroll a little bit lower, we can see this part of the logic that's going to end up doing the page merging. And again, we have to go work across different ranges. And this logic, for me to go right, I had to get pen and paper out and try to make sure that it made sense. From here, I want to go jump over to the test that I started to write. Starting with the result set test, this is where I had a bunch of scenarios that I started with, so it wasn't quite TDD, and I just want to explain why it wasn't quite test-driven development. So for me, when I start writing algorithms and it's something that I know that I'm going to be getting confused about, I go right to pen and paper. So in this particular case, when it came to trying to add pages in and then figure out how to merge them, what I generally do is almost like TDD, except it's with pseudocode and pictures. So I'm not actually coding up the tests ahead of time. I'm actually just trying to walk through a couple of scenarios to come up with the algorithm that I think is going to work. And I don't start with what I think is going to be the most optimal. I start with something that's going to function. If I have it working in the first place, that might actually be good enough. It might take a couple of iterations and I can see some obvious optimizations, but sometimes I just skip that until I go to benchmark it, and then if I realize there's some problems, I will come back and revisit it. But when I come back to revisit it, I already have tests in place, so I'm in a good position to be able to refactor it and have confidence. So it's not quite TDD because I don't go code up all of the tests, have them breaking, and then say, great, let me go start writing the code and make them pass one by one. Instead, what I do is I pick a scenario or two, and then I start making sure that it checks out on paper. So I start walking through my design and then going, okay, that doesn't work, let me change it. And I get one or two scenarios working. And then from there, I actually go code the algorithm first. I don't code the test first. So I still kind of start with the algorithm after I'm on pen and paper. And then from there, I might go, cool, it's compiling. I at least have a couple of scenarios I think will work. Then I add the tests. For me, this is really useful because it lets me check out that I've at least got part of the algorithm working as I expect, and I have some regression against that. From here, this is where it starts to turn into like TDD for me. So now that I have some part of the algorithm in place and a couple of tests that are passing, from there I can start going, well, what about this scenario? What about that scenario? And then I can see, usually pretty quickly, that I did not think of all these edge cases and my algorithm starts to fall apart. But that's cool because I know those base cases still pass, and then I can start iterating by adding additional tests and making sure they pass. So just to quickly reiterate, it's not quite TDD because I go to pen and paper first, get that kind of checking out, like doing some mental math and walking through it and drawing diagrams, making sure the pseudocode kind of checks out. Then I code part of the algorithm, then I code a couple of tests to make sure they pass. From that point on, it starts to turn into a little bit of TDD. And I just also wanted to mention that I don't apply this to everything. A lot of the time, I have a high degree of confidence in a lot of the code I'm writing. So for me, I might go write different types of unit tests or functional tests depending on what I'm working with. But this kind of TD, like half TDD approach, like pen and paper to TDD, I don't do that with everything. I do it with things that I have a low degree of confidence with. And like I said in the beginning of this video, it's almost always mapping ranges of data. Okay, cool. Let's go back to Visual Studio and check out some of the tests. So I have my result set test pulled up on the screen now. And if I just collapse everything and we start going through them one by one, just kind of looking at the titles of the tests, we can see how my thought process might have started to form up. Now, these aren't necessarily written in a sequential order that I created them in. However, we can probably have a guess at how I started and then some of the more complicated scenarios that came up later. for example, this test right here is to try and get a page, and we're asking for one page where the target is exactly what we have inside of the result set. This is probably one of the base cases that I worked with, and this is something I figured this should work and it should be easy to code, and the actual algorithm to make this happen is probably pretty simple. Again, without going through all the details of how my result set actually works, the idea would be that if I'm asking for a range and an offset, I can actually just check to see if I have a single page that's the right size, and if the offset was 0, then I know it's going to match. So for me, this is a really simple test case that I could go put together, and probably one that I started with right in the beginning. Another simple case that I probably looked at right in the start was this one here that says one page that's the target is completely before the data that we have inside of the result set. So if you look at this result set here that says from IDs 5 all the way up to 9, the important part to note is that it's actually starting at an offset of 5. So that would mean that if we were pulling data from a database, this is just an example, that we would be asking for a page that started at 5, and then we pulled an extra 5 IDs from that point on. So if we look at the page we're trying to get, this says start at offset 1 and get 3 IDs. So if you think about what I had just said, because this page that we have actually starts at offset 5, 5 absolutely comes after 1 plus 3, right, which is 4. So this entire page that we're asking for is totally before this page that we have inside of the result set. And as a result, this is a pretty simple one as well. We're going to get false for the return value, and the page that comes out is going to be null. There's going to be a very similar one, which is the exact opposite case where we have a page that's actually we're targeting completely after all of the data that we have in the result set. So this one we don't have to go look into, but if you see my thought process, I started with something that was exactly the same, something completely before, and something completely after. At this point, I probably had some of my algorithm coded up because I was able to walk through it on paper. But this is where it starts to get a little bit more interesting with something like this one here, where one page that's our target is partially before the data that we have in the result set. So if I go look at this setup here, we're actually saying, like the one that we looked at earlier, we're starting at an offset of 5, and we have 5 items that are in our result set. The page that we're asking for, instead of being at offset 1, is actually at offset 2, and we're asking for 4 pieces of data. So that means our page size is 4, our offset's 2, and we're going to be overlapping by 1 that's in here. Now, based on how my result set cache works, if we don't have a full page to pull back, we don't expect to get anything. And that's why we have a false here and a null page coming back, just like the other scenario. In the future, when I'm looking at different types of optimizations that I can use with my cache, I might actually allow something like try get partial page. And that would mean that this method still checks out to be the exact same, where when we don't get a full page, we actually say false. But if we ask for a partial page, and we used a very similar scenario like this one, that's where I might say, cool, we actually were able to get one of the items coming back. At this point in time, I don't have anything that needs partial pages, but in the future, when I'm looking at optimizations, like I mentioned, I might go explore that. I added a whole bunch of additional scenarios that I thought might be kind of interesting to go look at, but something that I wanted to touch on is this optimization that I have for my result set cache when we actually have the full result set pulled into memory. When we have the full result set pulled into memory, if you recall, I said I'm going to be merging pages together, so a full result set will mean that I have only one page, and it will be the entire range of data that we could possibly expect to get pulled back from a database query. And this is where some of the cool optimizations come into play, because I don't have to go iterating across different pages. All that I have to do is look at the single page and actually just pull the data out of that. So just to illustrate that, I'm going to jump back into the result set here. And if I scroll up a little bit further, you can see that I have this if statement that says if full set. And what we can do is actually see if we're asking for a page that is going to be within the full set. And I actually have this check here that allows us to ask for a page size that's beyond, right? So this kind of seems counterintuitive to what I said earlier. So if we were asking for a offset of 0, and a page size that actually exceeded the total count we have, I'm still going to return that page. And this is something that came up after I designed my algorithm when I was running my code with the cache in place. And the reason this came up is because most of the time I'm asking for page data for my database queries. However, there's a couple of situations where I just say int.max is the page size, and the expectation that I had as a caller was that if there's a full set of data, just go give me that. And I end up doing this because I know I have a couple of queries that are going to always return only like, say 100 to 1,000 records, and I do want all of them. I don't know the exact size, but I do know that I have a very small amount that can always fit into memory, and I just want to be able to pull everything in. So I ended up having to change this logic here and actually adding an additional test case that was not map exactly to this, but actually allow it to exceed. Now here's the fun part. In one of the last videos that I put out when I was explaining some of this code, I actually had a fix me left in here that said, I think that there's some more optimizations we can do when we have a full set of data. So if I scroll down a little bit lower, instead of having to use an iterator and then go step over each of these pages, adding things into a list, I said, hold on a second. We know that we have one single page. Now, this page of data has IDs, and the type that comes back is actually an I read-only list. However, there's a lot of optimizations that exist in .NET now that allow us to do faster operations on lists and arrays. And because almost all of the time I'm only using these two things as collections behind the scenes, I said, why don't I try writing a couple of optimizations specifically for these types? So generally, you won't find me ever writing code that looks like this, where I'm doing type checking and then some fancy logic for it. But this was something that I felt like because it's in a cache and it's supposed to be optimized for performance, I might as well try to squeeze out what I can, especially because there's a couple of things that we can use for collections here. So what was cool about this was that I could go add this logic in here, try it out, and see if I broke anything for my tests. And the reality is, I broke almost everything by adding this stuff in when I was looking at the tests that were trying to operate on a full set. And why did that happen? Well, it's because I really suck at mapping ranges of data. I knew that was going to happen. I knew that when I tried to go to approach this, that I was going to mess it up, and that's okay. I felt confident that I could go try this out because I had tests in place over the whole method already. And that meant if I was going to bust anything, no problem, I can go back and make sure that the tests are passing after. And as I mentioned, because I'm almost always using arrays or lists, what I found was that one of these scenarios was totally busted, and then the other one wasn't even executing. So I believe I was using lists almost everywhere and almost never using arrays. So I said, cool, let's make sure that the array path also passes. So if I jump back to the test here, you can see if I scroll a little bit lower here, I do have full result set array. I have full result set list. I have full result set other. And I put this one in here because after making sure that arrays and lists pass, I said, wait a second. That's going to mean that some of my other code is never going to execute. So if I scroll back into this result set, if you recall what I just said, if I'm always using lists and arrays, we'll basically never fall after this else if we're going through here. And that's going to mean that there's all this code that could go run after, and it's going to take one day where I put in a different type behind this IDs property, and that's going to break everything. So I said, okay, let me go add a test and let me make sure it's not a list and not an array. So if I jump back to the tests and we go look at this one in particular, I actually said for the result set page that I have in here, I'm going to make it an immutable sorted set. And an immutable sorted set is not a list and it's not an array. So this was really cool because I could go add additional coverage to this other scenario that currently doesn't exist in my code base, but I am going to have protection against going forward. And for me, adding these additional scenarios like this comes back to confidence. I am not confident in this type of code that has to go mapping ranges. So if one day I did have a different collection that was backing the IDs property, that was going to mean that I'm probably going to have a really hard time debugging this stuff because it just never seems to click. All right, so in summary, aside from me saying 100 times over that I'm really bad at mapping ranges of data, which is true, I'm terrible at it. It freaks me out every time I have to go do it. I still do it. Aside from that, I think the takeaway that I want you to have is that if you were thinking back to that thing that I asked you about in the beginning of this video, which is, what do you struggle with when you're programming? What comes up all the time and you're like, man, I know I'm going to struggle with this. If you think about my testing approach, how can you apply that to the thing that seems to always trip you up? So what I would suggest is for that thing that's always messing you up, get pen and paper out, draw pictures, go to a whiteboard, try getting your algorithm working. Try walking through it, making sense of it, and you don't have to worry about it being perfect, and you don't have to worry about it having the highest performance ever. I just want you to get the base case working, and I want you to feel comfortable with that just to start. From there, I'd recommend maybe giving it a shot trying to code up part of the algorithm. And when you think that might be working, go add a couple of tests for the base cases that you were working with when you were at the whiteboard or with pen and paper. Now you're in a position where you can start to build on some of that foundation. You have a partially working algorithm, and you have a couple of scenarios you can regression test against. Now it's up to you to come up with these other scenarios and think through if your algorithm can handle those. So this is kind of like where you might introduce TDD. And I don't think TDD applies to everything, even though some people swear by it, but I think this is a really good situation that I like to use it. So I'm hopeful that if you can follow this approach for the things that you seem to really struggle with, that you're going to have a way better time going forward, because the next time you encounter this, you'll say, not so fast, I'm not afraid of you anymore. I have a tool, and it's testing, and I'm going to use it. So I hope you enjoyed this. I hope you have a takeaway that you can go apply. And thank you for watching. We'll see you next time.